4.6 billion years ago, a massive disk of cosmic dust violently collapsed inward to form the planets we know today. Out of that exact same swirling material, two neighboring worlds were born side by side. If you sliced them open back then, you would have seen identical internal structures. Both possessed heavy iron cores wrapped in thick rocky mantles, and both were almost exactly the same size. During this early period, both planets cooled enough to form massive oceans of liquid water across their surfaces. They shared the exact same chemical ingredients necessary to spark biological life, but their paths eventually diverged. Today, Earth is a thriving blue marble, while Venus is a toxic 880-degree inferno, a world so hostile it has earned a nickname of Earth's evil twin. Today, Venus serves as a warning. By tracing the moments where these identical twins began to separate, we can see exactly what happens when the natural systems that keep a planet habitable begin to fail. Earth's tectonic plates act as a global thermostat, recycling excess carbon dioxide into the mantle. Venus never developed these shifting plates, leaving its crust entirely stagnant. The gas rapidly accumulated, creating a dense blanket that traps incoming solar radiation, bouncing heat back and forth continuously. As the global temperature steadily climbed, those ancient, life-giving oceans began to evaporate. Eventually, the heat completely boiled the water off the surface, venting it out into the vacuum of space. What remains is an atmosphere piled so thick with carbon dioxide that the surface pressure is 90 times greater than at sea level. Standing on the ground there would feel exactly like having a small car resting directly on your thumbnail. The single absent geological mechanism, the lack of moving tectonic plates, allowed a potentially habitable water world to bake into an inescapable pressure cooker. Down on the ground, the temperature rests at a lead-melting 880 degrees Fahrenheit. Because the atmosphere is so dense, there is virtually no wind and absolutely no water to erode the rocks. Instead, the landscape is heavily scarred by continuous, slow eruptions. Radar mapping reveals over 1,600 major volcanic centers dominating the terrain. The extreme pressure shapes the eruptions into bizarre geological formations. These are pancake domes, massive, circular mountains created when highly viscous lava slowly oozes outward and is immediately pressed flat by the immense weight of the air above it. Other eruptions create tick domes, which are strange, creeping volcanic formations with radiating spurs that look exactly like the legs of a feeding insect. To even photograph this environment, Soviet engineers had to drop heavily armored titanium landers onto the planet. Even encased in thick metal, the most successful of these probes barely survived for 2 hours before they were crushed and melted. It is a geological graveyard, locked perfectly in time by extreme heat and pressure. But if you travel 30 miles straight up from that dead surface, the environment suddenly shifts. Here, high in the cloud layer, the temperature and atmospheric pressure eerily mimic a mild spring day on Earth. Whipped by hurricane-force winds, the tops of these clouds feature persistent dark streaks. Despite the violent weather, these streaks remain stubbornly intact and continuously absorb ultraviolet radiation from the sun. This chart shows the atmospheric absorption spectrum measured directly within that temperate layer. It shows a sudden spike, indicating the presence of phosphine gas. On our own planet, this specific molecule is a distinct byproduct of living, breathing, anaerobic ecosystems. This points to a radical hypothesis. As the planetary oceans slowly boiled away millions of years ago, microscopic life might have caught thermal updrafts, migrating into the sky to survive the rising heat. The survivors of a dying world may have simply relocated, turning the clouds into a high-altitude biological refuge. Living in this aerial oasis comes with an extreme hurdle. The clouds are not made of water vapor. They are composed of highly concentrated, toxic sulfuric acid. Astrobiologists suspect microorganisms survive by linking sulfur atoms into a protective, ring-shaped coat. This chemical armor repels the acid and absorbs incoming UV light for energy. These microbes could also photosynthesize ammonia, pumping it outward to neutralize the droplet's acidity, engineering their own microhabitats. We will soon have hard data. In the 2030s, NASA's Veritas and Da Vinci missions will plunge directly into the haze to test these exact chemical anomalies and sample the atmosphere firsthand. If these cloud layers do harbor survivors of the ancient oceans, it would mean that Venus is more than just a graveyard. It would suggest that even after a global catastrophe, life can adapt to persist in the most unlikely of places.